So now let's see how we are mapping this cuff pressure with Korotkoff sound. Okay. So this graph, the upper graph is nothing but is a cuff pressure. Okay, so the cuff pressure, the pressure we are giving to the cuff, that is the upper graph. And in second, this graph is your Korotkoff sound. Okay, appearance and disappearance of Korotkoff sound. And third graph, there seems to be like sinusoidal waveform, right? That graph is nothing but your blood pulsations. Okay, that is the flow of your blood. So just we will map how the graph is going on when you are increasing and decreasing the pressure. Okay, so initially like you are at resting state. Okay, initially at resting state you are not giving any pressure, so it is in almost horizontal line. Then you are going to give pressure, that is you are going to inflate the cuff by pressing the bulb, right? So this is the point which represents the inflating pressure. Okay, the duration, the inflating duration means this is the duration where you are going to inflate the cuff by pressing the bulb for a certain period. That is the point up to the point the above systolic pressure. Okay. Then what you are doing, once it reach that pressure, now you are going to release the pressure. Okay, first part is inflating, so you're inflating the cuff by pressing the bulb. And then after reaching that cuff pressure above 130 or 140 mmHg, now we are going to slowly reduce the pressure by releasing the screw. Okay, so now what's happening, the curve is going down, it means that you are slowly releasing the pressure. Okay, so now that is one point. As I said before, you will start to hear the sound. Okay, that point is nothing but systolic pressure. So if you see in straight away, that is the point where the Korotkoff sound will start to appear. Okay, so the point where you are hearing the systolic pressure, that is the point where the sound is start to appear. So in before case, during inflation and also resting place, also resting time, during resting time and during the inflation of the cuff, you are not going to hear any kind of sound, because in resting state also the blood is like flowing normally without any disturbance, so you are not going to hear any sound. And during inflation your blood is now starting to, blood vessel is now starting to shrink, so it means that the occlusion is happening, so there is obviously there won't be any proper flow. So due to this again there is won't be any sound. So where you will get the sound, in the sense the moment when you are releasing the pressure, the blood now is finding the way to flow very hardly. So because of the turbulence flow, it will hit the blood vessels hardly. Okay, so as a result it will produce the sounds. That is the point. We can also say for a systolic pressure, at the same point you will hear the Korotkoff sound. And again when you keep on releasing the pressure, at one point you will no more hear the Korotkoff sound. So that is the point you will naming as diastolic pressure. Okay, so there is 2 point, one point the starting of sound and another point is ending of sound. So starting of the sound is systolic pressure, ending of the sound is systolic pressure. Why you are naming that systolic pressure in that point, in the sense that is mean that now your blood vessel is being released as much as possible, so the blood is flowing normally as like before. It follows their normal laminar direction, so there is no way it's going to disturb or hit the blood vessels hardly. So as a result, no, there is no possible to produce any sound. So that is the reason here this point we are taking as a diastolic pressure. When you compare this two graph with the blood flow, again in resting and deflation, in resting state you have normal blood flow, that is the sine wave you can see here. And then followed by during deflation, this sine wave will start to gradually reduce. You can see the gradual decrease of the sine wave. The reason is that now your cuff is keep on inflating, it will going to shrink, contract your blood vessels. So when your blood vessels keep on contracting, automatically it will disturb the blood flow in the blood vessels, so the sine wave is keep on decreasing here. And then there is a one point, that is the full occlusion. That is you are giving pressure above 120, right? So during that point you will no way see any graph, that is a sine wave there. The reason is that there is no blood flow at all. okay. And then when you are slowly releasing the point, okay, releasing the pressure, the sine wave will start to reproduce again. The reason is that whenever it's keep on releasing the pressure, now the contracted blood vessels will start to expand, okay. So whenever it's expanding, the blood now will find the way to flow freely. So initially you will have minimal flow, and then as long as its pressure is decreasing, the blood vessels also expand, so blood flow will also increase. So it will keep on increase. At one point it will get to steady state. So this is the blood pulsation graph, okay.